Hi, I'm Konshu.
I'm Matt Metcalf.
I'm Josh Myers.
And I'm Eric Johansson, and we're seniors in industrial engineering at Iowa State, working with the company Winnebago for our senior capstone project. This project was conducted in spring of 2018, and it was involving the welding department 773 and 765 at Winnebago, and they had a projected demand in 2020 that required 25 welders. So the objectives for this project were to eliminate overtime, verify and increase the value-added time, and increase the value-added time to meet the future demand without using any overtime.
Before the CSA, we do not know what's happened in the factory, so we decide to do the work sampling and finding what's going on. Work sampling study basically is a study that observer working through these two departments will fix the working path and frequency and record welders' actions at specific moment. During the working sampling, we found out that there are actually two working phases. During early morning of the day, the welder will working individually, but afternoon of this day, worker will help each other or staging material for next day, which means the welders sometimes have to do material handler's job, and they could not working very efficiently, even they're welding and positively to work.
Here is our brownfield layout. We based the work cell sizes on the current size with some resizing in different cells. We also moved work cells that produce blue assemblies near the blue finished assembly area, and moved the black assemblies near the black finished areas. Racking was moved near the aisle, and the aisle was standardized.
This is our greenfield layout design. The things that we want to do for this design were a few things, like reduce the material handling walking distance, add a tow tractor, standardize the racking against the aisleways, and reduce the space used. So for the racking, we wanted it put against the sides along here, here, and here.
So the material handler will go along here and come around and go back and then go to reach these other cells here. And since the racking is along the edge here, he can go along here, pick up parts, drop off parts, pick up parts, drop off parts, pick up parts, drop off parts, and move along so he can get his job done faster.
We use the pole planer to analyze our brown and green fields. Pole planer is a great tool to analyze the material flow and frequency. After record all the material data from Winnebago, the pole planer calculate the working distance, time, flow, and show the results.
When looking at the work sampling data, welders were tasked with moving finished parts and delivering parts in Phase 2. This large percentage of time for these tasks will now be done by the material handler. To accommodate this, the brownfield and greenfield layouts improve the material handler's job. The brownfield had a reduction of 17% walking distance compared to the current state. The greenfield had a reduction of walking distance of 70% compared to the current state.
This is our return on investment. As you can see, there's three different layouts here. The current state, the greenfield, and the brownfield. The current state has 2 material handlers, the greenfield has 1, and then the brownfield has 2 material handlers. The current state has the least fixed cost, and the greenfield has the largest fixed cost because it needs a tow tractor and just reinstalling the cells. The current state had the most savings, even though it won't entirely reduce the overtime. The greenfield was the second most savings, and it does reduce the overtime with just 1 material handler. And then the brownfield finished the worst with savings, and it requires 2 material handlers.
So this was a summary of our senior design project in spring of 2018 at Iowa State. Thanks for watching.